Hello, I am Olunlade Joshua and I am going to be taking this brief tutorial on liquids in motion. Now, the basic principles of liquids in motion. Flow. A fluid consists of a large number of individual particles. They move in the general direction of flow, but they are usually not parallel to each other. The velocity of any particle. This um, this shows the movement of a particular particle at different instances of time. So now the path followed by a particle is called a path line. So this is a path line. This is a path line because it is the path followed by the particle. When this is point 1, point 2, point 3, point 4. At any given instant of time, the position of successive particles can be joined up by a curve which is tangential to the direction of motion of the particle at that given instant. This curve is called a streamline. Ordinarily, this curve is supposed to be in 3 dimensions, but due to the limitation of this, it is shown in 2 dimensions. When considering a larger body of fluid, it is sometimes convenient to consider a small cross section. If streamlines are drawn at every point on the circumference of a small area, they form a stream tube, such as this. The fluid inside a stream tube cannot escape and can be treated conveniently. So this is more easy to treat than this. Please bear that in mind. We're going on. Now, considering the types of flow, we have two main types of flow. We have the turbulent flow and the viscous flow. Now, what do we mean by turbulent and viscous flow? The turbulent flow is a type of flow in which the particles of the fluid move in disorderly manner, occupying different relative positions in successive cross sections. That is, in turbulent flow, there is a disorderly movement of particles, while in viscous flow, which is also known as streamline or laminar flow, the particles of the fluid move in an orderly manner and retain the same relative position in successive cross section. So basically, turbulent is disorderly and viscous is orderly. Orderly movement of what? Fluid particles. Disorderly movement of what? Fluid particles. Now, Osborne Reynolds discovered that the type of flow of any fluid is given or determined by its velocity, density, viscosity of the fluid, size of the conduit, and the Reynolds number. But what is the Reynolds number? What exactly is the Reynolds number? The Reynolds number is given by this formula: PVD over that over N. PVD over N, where P is the mass density, V is the mean velocity, D is the diameter, and that Greek symbol is the velocity of the fluid. That is the Reynolds number. Now, definitions of basic terms in fluid in motion or liquids in motion. Uniform flow. The cross-sectional area and velocity of the stream are the same at each successive cross-section. Things to note here: the cross-sectional area and velocity of the stream are the same at each successive cross-section. What does this mean? Example is flow through a pipe of uniform bore running completely full. That is, when you have a pipe of uniform cross section like this, the flow is going to be uniform. Flow will be uniform because the area here and the volume, the area here and the velocity here are going to be the same as the area here and velocity here. The cross-sectional area and the velocity of the stream are the same at successive cross section, so it will be the same at this cross section, it's going to be the same at this cross section, and it's going to be the same at this cross section. This is uniform flow. Now steady flow. Steady flow, the cross sectional area and velocity of the stream may vary. Note that may vary from cross section to cross section, but for each successive cross section they do not change with time. What does this mean? Example of that is flow through a tapering pipe. Let me illustrate that here. When you have a pipe that looks something like this, sorry about the diagram, it's a bit okay. When you have a pipe that looks something like this, the area here is bigger than the area here. That is, A1 is bigger than A2. That is, A1 and A2 are not the same. The volume here, the velocity here will be different then from the velocity here at the second cross section. Now, according to the definition, steady flow, the cross-sectional area and velocity of the stream may vary from cross section to cross section. So the flow will vary from this cross section to this cross section because they do not have the same area and velocity. But at this cross section, it will be the same. How do I put it now? The flow will be the same. It will not change with time. At this cross section, it will not change with time. That means after time 2 seconds it won't change, after time 3 seconds it won't change, and at this cross section too it won't change. It will remain constant with time, but it will vary from this cross section to this cross section. I hope it's clear. Now, on steady flow, the cross-sectional area and velocity of the stream at any cross section will vary with time. Example, a wave traveling through a channel, something like this. Let me draw the even pipe we had in steady flow. This is the even pipe, but when you have the wave flowing something like this, like a wave structure, when you have the fluid flowing like a wave, it will not have the same velocity at any cross section. So that means that the velocity of the stream will always vary. It will not be the same. And now, what is mean velocity? The mean velocity v at any cross-sectional area A, when the volume passing per second is q. Will be v, which is the mean velocity, is equal to q over a. V is equal to q over a, where q is the discharge and a is the area, cross-sectional area. The discharge is the volume of liquid passing a given cross-section in unit time. What does this mean? It is denoted by Q and its unit is cubic meter per second. That is meter cube per second. Basically, discharge Q is given as volume per unit time. That is why the dimensional quantity is meter cubed per second. So in the next video we will treat continuity of flow and under what conditions does continuity of flow exist. Thank you. Please subscribe to this channel and ask your questions in the comment section below. Let me know your thoughts also in the comment section below. I am Olunlade Joshua and this is Liquids in Motion, Fluid Mechanics.